Hi guys, today I would like to show you my project, reverse engineering of the Tesla Model S drivetrain. As everybody knows, Tesla Model S is an electric car, and I would say currently it's the best production electric car on the planet. And it's funny enough, but there has not been many hacks of this car so far. I mean, the car is full of interesting stuff, but people don't seem to be using them much. So that's something we would like to change. And because there are two crown jewels of the Tesla Model S. The one is the battery, which you've seen already other people taking apart, and the second one is the drivetrain. Tesla drivetrain is an induction motor coupled with a gearbox. It's a single-speed gearbox with a differential with a reduction of around 1 to 9.7, and this motor is actually quite impressive. It can spin I think up to 16,000 RPM in the performance mode, and it can deliver 310 kilowatt of power, and currently is the best motor you could put in an electric car. It is water cooled, very well designed, even has a rotor water cooled, which is quite unusual feature. I don't think it has been done before in any other application, but Tesla managed, and they did a very good job at designing this drivetrain. And today we will look on it. I will show you some pictures, and we will see if we can use this drivetrain to spin some motors. So stay with me. Here you can see the Tesla inverter. I've already stripped it down a bit. From this side is where the inverter is connected to the drivetrain. You see the coolant entries and also the three-phase connections, the proper bus bars. Now, this central assembly, that's the differential with the gear reduction. The gear reduction is around 1 to 9.7 or something around that. And here I put a orange sticker just so you can see when things will be spinning. And inside are the drive shafts. There's one on this side and one on the other side. Now here in the back is the motor. This motor is quite a beast, rated almost at 300 kilowatt. Now this unit is a bit special because it doesn't really come from Tesla Model S. It does come from a Mercedes-B electric, which explains the black frame, which is I would say not really standard on Model S. And I also, as I've heard, on Tesla Model S there is no parking pole, while here is it's located here with this, something I would presume is a stepper motor that just turns the brake on and off. Now, the interesting thing is that this drivetrain is used in several cars, not just in Tesla Model S, but also, for example, in the Mercedes-B electric and some others. And it seems that they are all the same. So the only difference is in the software. So basically the Tesla inverter and the Tesla motor and the gearbox is pretty much always the same. I didn't see any differences in the topologies. But what's different is what is written in the firmware of the inverter. So the power limitation is just a firmware feature. which is quite interesting because then it leaves quite a lot of space for possible upgrades of the lower end models. Now here you can see the Tesla inverter. This beast has a very interesting construction with 3 separated faces, basically folded into a triangle, and the 3 motor outputs, 3 bus bars. Currently I'm using these current sensors, which are from Chevrolet Volt, but these bus bars actually have current sensors included inside of them. You can see them here. It's basically a segment of a bus bar. It has a different resistance, and this resistance basically creates a voltage drop, which is then measured by this small board, provides the feedback for the current measurement. But I'm not using this one because I'm running very small power levels, and for tests in apartment like my test, it's better to use let's say lower current sensors. These bus bars, they should be good enough for 1200 amp, so the sensors will be scaled like that as well, which is a bit too high for a domestic application. And from the front you see 2 main bus bars that connects the DC voltage, some external connectors, and lots of electronics. Here are the individual Lgbtq transistors. There is quite a few of them. There is one row here, the other one is hidden under this capacitor bank. All the segments are symmetrical, so this is repeated 3 times on all sides for each one of the phases. And this is where the original motor controller was sitting, on this plate. Now, one way how to reverse engineer such a thing would be to just capture a CAN recording of the bus of a working car, and just simply repeat it to such unit. And if everything goes well, this should give you basically a spinning unit outside of a car. But that's not the path I choose, because I don't think it's universal enough. So here you can see my toy. I call it a UMC Drive, and basically what it does is that it adapts to the original inverter, and basically reuses all the power stages, all the drivers. You can see the phase drivers here for the high and low side. So it reuses all the sensors, all the drivers, and all the power parts, as well as the cooling and so on, and just provides a different brain that is capable of driving motors in both sensor as well as sensorless field-oriented control. And this basically allows you to teach your inverter any kind of motors you might have. So once you have a board like this, and if it's designed universally enough, you can actually use different power stages with different motors. You're not just limited in using the Tesla inverter with a Tesla drivetrain. You can actually pick any combination of drivetrain and inverter you like. So for example, I'm going to show you in the next part where I'm spinning this Tesla motor with an inverter from Chevrolet Volt. So you can do that pretty much with anything. I mean, here I have a Prius inverter. This is a Toyota Prius 2nd generation inverter, and which I reverse engineered quite some time ago, and you can use it as well. I mean, I can take it right now I can connect it to the Tesla drivetrain and I can spin the Tesla motor with Toyota Prius inverter. All you have to do is to replace the brain and everything else remains the same. So now for the setup. Since I'm running this setup in a very small flat, I had to optimize a bit, so I cannot use lots of batteries here because it's very confined space. So I got this power supply, which is 75 volt 14 amps, which will be enough for some low speed tests that I want to show you. Then there is my old trusty multimeter, small power supply that actually that just provides the power for the UMC Drive and for the inverter, the 12 volt, and an oscilloscope showing an encoder signal from the Tesla motor. The Tesla motor is using a normal Hall effect A and B encoder to sense the rotor position, but we are not going to use it on this video because we are going to run this drivetrain in a sensorless mode. People usually are a bit afraid of sensorless setups and they think that they cannot drive a car, but I have a Volkswagen Golf that does not know this, fortunately, and it runs quite nicely in a sensorless mode. Of course, you can connect an interface for the encoder if you wish so, and compare the performance and do things like this. Okay, so now everything is wired together. You see the UMC Drive connected to the Tesla inverter with all the drivers interconnected, voltage feedback and the current feedback, and cables go inside of the motor, connected to the three phases of this induction motor. Now what we are going to do is we are going to try to spin it. We will start really slow in the beginning. Going slowly up. And the sound you can hear in the background, that's actually not the motor making that sound. It's actually our washing machine. So that's not really related to the experiment. So just try to imagine that the sound is not there. So as you can see, the motor is spinning. The shaft is spinning happily. We cannot go too fast at this moment because I don't want this drivetrain to leave this room and roll somewhere else, which already happened to me in the past with a different motor, and I do not wish to repeat that. Especially the wooden floor does not like square rotating objects. So on the scope you can see an encoder signal that right now we are not using the encoder in the application, we are just displaying. So we can slow down, you see that the frequency goes down. This is the frequency of the motor. And we can stop it. So the most annoying thing on this drivetrain was this parking pole, which I didn't really know is there. And that's operated with this small motor. Originally I thought it's just a readout of the gearbox speed, but okay, that was quite of a gotcha. I thank people on the forum who actually pointed this out because I was getting a bit desperate. Since using the Tesla inverter, I already managed to spin every motor I have here in the apartment, but I mean, not all of them worked except for the Tesla motor, which was the one that I wanted to spin, and it didn't matter how much current I put into it, it just didn't spin. and the problem was very obvious. I mean, it was just in the park, and all the documentation I've seen about Tesla motors didn't mention a mechanical part. So I would say that it was either added for the Mercedes, or maybe every Tesla has it, I just never really saw it. Anyway, this is now out of the way. We can happily spin the Tesla motor with a Tesla inverter. And now I would like to show you pretty much the same thing, but with a Chevrolet inverter. Okay, so now we reconnected the inverter. So we are using the Chevrolet Volt inverter with the motor controller. As you can see, all is as it was before. We have the control and we have the feedbacks for the current and for voltages. And we are going to do a test with this Chevy Volt inverter. We will basically repeat what we did last time, just to show that it doesn't really matter what kind of inverter you want to spin your motor with, that with this board, with the UMC Drive, you can really pick whatever inverter, whatever motor, you can spin it together. Doesn't make a difference. As long as you get the scaling right. For example, this Chevy Volt inverter, you could push, let's say, 130 kilowatt out of it, while the Tesla motor would be happy even at 300 kilowatt. So of course you would be losing some of the power if you use, let's say, Chevy Volt inverter compared to the original Tesla inverter. But it can be done, and from the software it's actually running exactly the same software as it was running before with the Tesla inverter. The only thing that changed is how the board communicates with the inverter, and all the motor parameters, everything remains the same. So let's spin it. Okay, again I'll start very slowly. I will put it. Yeah. It would be good to actually turn on some power. Okay, so we are running 75 volts, and this power supply is good up to 15 amps. Okay, so now it should be possible to do some spinning. Okay, let's put it up a bit. Well, as you can see, the shafts are spinning. So here on the encoder signal, you can see that we are getting around 90 Hertz. I don't remember exactly how many encoder lines are in this motor. I think it's like 1024 encoder lines for one turn. So we are spinning, and it seems to be working. We can slow it down again. Okay, and let's stop it. And now it's time for some pictures. Here you can see the chassis of a Tesla Model S in some showroom. This is a very good picture because they removed all the cables and they polished it really nice. So you can see the motor, the gearbox with its differential, and the inverter casing. It's a nicely joined one unit. I would say quite nicely balanced as well. And this configuration gives Tesla quite some competitive advantage. Here is the actual unit I purchased in Germany. It's you can see it's quite a beast, including the ugly black subframe that Mercedes is using for their electric car. because this drivetrain comes from Mercedes B electric. It's a bit damaged on this side by crash, but nothing that welding wouldn't fix, fortunately. And I got it for a decent price as well. And just had to transport it from Germany to Switzerland, where is the place I currently live in. And originally I'm from Czech Republic. Now getting this around was not so easy, because I had to fit it in a Peugeot 206, which is not the best car to transport Tesla motors in, but at the end we managed. And yeah, it's quite a big piece. So even though in Germany we had machinery to put it in the car, I was a bit worried how are we gonna get it out. And here you can see, as we stopped on the way already in Switzerland, we had to stop by next to a supercharger just to show a picture of a Tesla drivetrain in a Peugeot 206, as it is the first Peugeot carrying a Tesla motor, most likely. The owner of the white Tesla behind was quite surprised to see his motor in a car, and it's not Tesla. And at first he didn't really believe it's the real thing, but at the end we managed to convince him. Now this is the motor as we transported it to a friend of mine. Fortunately he had a crane for lifting the engine, so we managed to get it out of the car. And since there was no way I could get it in my apartment at the time, I decided to strip it down a bit and to take only the inverter to my place, because that was the part I was mainly interested in, to see if it can be reverse engineered, if I can reuse it for some other projects. Because at the time when I bought this, there was nobody in the world that managed to reuse this drivetrain, so it was a bit of a long shot and a bit of a risky investment to get a thing like this. But I was pretty confident that given enough time, it will be possible. And I mean, having a Tesla powered car, it would be just an amazing project. So I said, okay, let's go with it. Now, if you remove the top casing of the inverter, you find out that it's pretty crowded in there. The Tesla inverter is built out of 3 segments forming a triangle, where on top you have the main bus bars that distributes the high voltage DC to individual segments, and each segment is one phase for a 3-phase motor here on the bottom. Here is a motor controller that Tesla is using, so this was the part that I had to replace. There is, of course, you can just replace some CAN captures to it and make it spin outside. But since my unit actually came from a Mercedes B electric and not from Tesla, the Tesla capture would not really work with my drivetrain. I mean, I could play the whole capture of a car to it and it would not do anything. And since this is not even a production one, I'm pretty sure that this was a unit from a test car. I'm not even sure if it will do anything, even if you had the Mercedes B electric CAN capture. So from the beginning I decided, okay, I will have to really go through it, reverse engineer it, replace it, and drive the Tesla motor with my own solution. Here you can see the Tesla drivetrain without the inverter. Here are some nice cooling lines for each phase and a bolt pattern. And here are the main bus bars that go through the gearbox to the motor and provides the 3-phase power for the motor. And here is the Tesla inverter on the table. The reason why I why I even considered buying it without knowing anything about it was that recently I've spent some time developing a motor controller that was from the beginning designed to be as universal as possible. Thus, the name UMC Drive, and I've already managed to use this motor controller to drive different power stages from different cars, namely the Chevrolet Volt inverter and the Toyota Prius second generation inverter. I also did some bit of a reverse engineering of the third generation of Prius, several industrial inverters, and poked a bit around the Lexus, which is also Toyota technology. And here you see the Tesla inverter from the back with the cooling lines and very nice solid bus bars. The interesting thing here is this discolorated part, which is actually a current sensor. So by increasing a resistance of this part of a bus bar and placing voltage sensing on top of it, you can measure the drop and thus knowing the current flowing through the bus bar. So of course you need at least two current measurements, and that's what's being done here. These bus bars in the high performance unit, I think they are supposed to carry around 1200 amps. Of course not for an indefinite period, but you can see that there is a lot of copper here. And these are the boards when I receive them from production of my UMC Drive. This will be the boards that will drive my inverter from Tesla, as well as the Chevrolet Volt and Toyota and other inverters I feel like using. It's bigger than for a Tesla. It has actually dual motor outputs because Chevy Volt and Toyota Prius actually use a dual motor setup, and I wanted to have the same capabilities. Also, there is a CAN on this board and USB interface and everything you would expect from a motor controller that goes in the car, including all the protection and separate power supply and DC-DC converters. And here is the minimal setup of such a motor controller that is able to drive pretty much any inverter. All you need is some sort of a PWM control for the high power stage. Basically, the best you can do is to reuse the original high power drivers for the IGBTs and just interface to it with a proper logic, usually with differential PWMs and with the correct voltage scaling. Then you need some voltage feedback to measure the bus voltage, the free phase voltages, and so on. And you need the current feedback. Here connected you can see the Chevy Volt current sensors, but you can use different ones from either you can make your own or reuse the ones in Tesla or in Prius. Doesn't really matter. The board is designed such that you can plug pretty much anything in it if you just wire it correctly and set up in the firmware. And here is a setup with a Chevy Volt inverter. Basically, this was the reason why I bought the Tesla Drivetrain. I mean, I already knew that this system works with a lot of inverters, and what's the most advanced inverter currently in the market? That's the Tesla Model S inverter. So I said, okay, if my design works with a Tesla Model S inverter and drivetrain, it's will work with pretty much anything. So that's why I took this risk investment in the Tesla motor. Here you can see a picture of the reverse engineering of the Chevy Volt inverter. It took some time, but it was definitely much easier than doing the Tesla. Tesla was a bit of a bit of a challenge to do. It's quite well designed, quite compact, and difficult to reverse engineer. Then, when I was confident enough I can reuse the Tesla Model S inverter, I said, okay, now is the time to actually try it with the Tesla motor. And for that, I had to transport the Tesla motor to my flat. Fortunately, my friend was nice enough to help me with that, and we loaded up the drivetrain, including a crane, and went to the city center to my apartment to move it inside. At the end, we managed. It's sitting quite nicely in the corner, and you saw on the video that now it's all wired up and running. So I would like to thank you for your attention, and if you have any questions, feel free to write me an email or visit my website. There is nothing much on it right now, but I intend to fix that in the incoming days. Thanks, guys.